So yeah, started talking about objects, and we started making an enthusiastic student object. But we only had just started. We basically got to here, right? I'm going to get rid of some of the extra comments just to get things fitting on the page. And fix the indenting to match Colab a little better. There. Whoop, nope. So once I do this, what this means is Python says, oh, okay, they're going to define a class now. All the code that I'm going to see is the definition of a class. Kind of like when it sees def for a function, it doesn't like run that code until you tell it to run that code, right? You could define the function, you call the function. Here, we're defining the class, and eventually we'll create the class and use the stuff within it. But in the same sense that we're writing the code, but the code's not running unless we tell it to like make an enthusiastic student object and call some of the methods or whatnot. So here we have the start of the definition, class name, colon, indent, and then init. And of course, underscore, underscore, init, what do we call that special function? What? No, it's not init. It's not an initializer. It's not, what do we call it? Come on. Constructor. Of course, you didn't have to say it as if you didn't know. Of course you knew. It's a constructor. And this is the function that's called whenever we create an instance of this class. So student A equals enthusiastic student and Bob Smith 9 and 74, right? And just to prove to you that this code does run, we'll rerun that. Okay, now I'm going to call this to run the, call the constructor. Oh, what did I do wrong? Where? P-R-I-N-T. How about that? There we go, cool. So we can see that this line of code, like all of the code inside this constructor ran. And we convinced ourselves because we put a print statement in our print, we called the print function in there and it printed it out. So we know it ran. And all of this stuff runs whenever we create an instance of the object. And a lot of times, sometimes your constructors are going to be hilariously simple. Even simpler than this, where you basically put nothing in it. Sometimes they're going to be really complicated. Like on the assignment 4, well, complicated is not the right word, but they're going to be a lot more involved. On assignment 4, your constructor will load up a file, load in data from the file, and just kind of arrange things. So the constructor has a lot more to it, but it's still all just that initialization stuff. So the constructor, it gets us, and we call it whenever we make an instance of it, and it's designed to kind of do like the prep work for that object. And it has to be called init, underscore, underscore, init, underscore, underscore. And then what's up with this weird self thing? Remember, it's weird, right? But it's a reference to itself. And we saw at the end of last class where I showed you that EQ method that would compare two objects. And we access the individual values, the attributes, through the reference to the object I want the attribute from. So sometimes it'll be like, okay, tell me your first name. And sometimes it's, tell me my first name. I know it seems silly, but it's how we do it. And if you're asking why, it's because someone somewhere said, we're going to do it this way. And that's the way it is. I never really liked those types of things in computer science, where, why do we have to do it this way? Why is this not even a convention? This is a rule, right? There's a lot of things, like linear search. When you think about a linear search, if I say you start at the beginning of the collection, you look at each of them, and if you ever find what you're looking for, you found it. If not, you keep looking. If you ever get to the end and you don't find it, it's not there. What I just described to you is a linear search algorithm in English, but we all know the code for that. And that algorithm, like there's no like weird convincing of like, well, why does it work? Well, because that's how it things work in our universe? It's kind of a silly question to ask, really. Well, why does the linear search work? Because it does. Like that, the actions you're doing does that. Where here, if you ask the question, why do we have to use self? The answer is because someone made us do it that way. And whenever I kind of got to those like engineering decisions where we have to follow this rule, I always kind of felt that was a little annoying. But it's just what it is.
If we, instead, because we could change self-goal whenever we want if we chose to. If we didn't put it as self, would we lose points?
Absolutely you would. Remember, just because it gives you the answer doesn't mean it's correct. And computer science, a lot of students are like, but it's like math, it's right or wrong. No, you're being silly, it's not. There's a lot of qualitative analysis of what goes into it. It's marked not like an essay, but more SAE than like a math test, you know? Where it's like, okay, yes or no, did you follow the steps? Because there is a lot of interpretation. Because sometimes you miss a certain number of edge cases. It's correct for the most part, but not quite there. How do you mark it? Well, it's better than theirs, but it's worse than theirs, and they got a 3, they got a 4. So how do I, it gets hairy. So it's not easy, but if you're breaking a convention, that's not even like oh, here's the convention we follow, you do it this way. This is a very strong convention that if you don't follow it, that's really bad. Because if you ever gave it to another programmer, they're going to be like, what the hell is this? What on earth is, what's going on here? It's not going to make any sense to them. And that's a big problem. So here I added a number of methods to the class. So I'm just going to go back up here and just paste it in. Now, pay attention to the indentation level of these methods. Functions. They're methods because they're part of the class. Right? So they're aligned with the constructor. See? They're indented within the class, but they're aligned within the constructor. If you did this, like your code will run, but the problem is the function, or like the method ask for higher mark, only exists inside the constructor, which is silly. We want it to exist for the whole class, not only within a specific function. So we just have to be careful about that. And this can get tricky because if you hit run and it's not in the right spot, it'll run and you'll think like, yeah, everything's working fine, it's happy. But then it's going to start saying like, well, there's no method called ask for a higher mark. But it's right there. Well, it's because you're trying to call it from an area that it can't see it because you accidentally put it inside another function. So just be careful about your indentation. So here I have a couple of methods here. They're silly, okay? Like one is ask for higher mark. Hello, professor, my name is whatever their first name is. And I'm in your class. I really like if you could just give me a higher mark, thanks. That's all it does. It's rather silly, okay? But if I call this method, I'll rerun this. And we'll make another student. What's the student's name going to be?
Tom.
Tom. Tom what?
Paul.
Tom? Tom?
Paul.
Oh, Paul. Okay. Okay. So we have Bob Smith and Tom Paul. Is Tom Paul someone famous? I don't know. No?
Yeah, just pick 2 random names.
Perfect. Good enough. So I hit run. Okay, great. I created 2 students. I have 2 enthusiastic student objects referenced by the variable student A and then student B. By the way, what do you think would happen if I said this? What do you think would happen?
I want to guess that it would be similar to a list.
It's going to be exactly like it. It's going to be an alias. It won't make a copy. So if I have 2 things referencing the same enthusiastic student, we're in trouble if that's not really what we wanted. Yeah? What you would effectively, no, not with slicing, but you would effectively make a way to like make a copy of an object. There's an easy way to do it. In fact, there's built-in like modules to do it for you easy. But that doesn't matter right now. So there we go. We have 3 variables that are references to students, but only 2 students. But let's get rid of student C just because I don't want to create any extra confusion that's not needed. So if I say student A dot ask for a higher mark, how high of a mark do they want to ask for? Just give me a number. 100. Okay, great. I'm taking 100 just because it's bigger. And it's something a student would do. Great. Look. Hello, my name is Bob. Well, yeah, because student A, which is referencing the enthusiastic student whose attribute first name is Bob, their name's Bob. We go to the end, it says Bob Smith, right? Makes sense. And then, but if I change this to B, well, it'll be Tom Paul, right? Because I'm telling another student to run the method. They're the same method, it's just one, you're telling a specific instance of the students to do it. So this instance had different attributes, so when you ran the method, it used the values in the attributes accordingly. So student A, well, it's Bob Smith. Student B, Tom Paul. Any questions about that? Nothing. Okay. And of course, we have this show off. This is one of my favorite ones. Show off. What's it going to do? I got 100 on my last assignment, everyone. I'm a wizard. And then what does it do? Well, it changes their first name to wizard. Why? Because. It's just a silly example. And this method actually changes the value of one of the attributes. Why? Because. So let's test it. So let's say print student A first name. So if I print student A's first name and then call show off, does show off take any attribute? No, it does not. And then we'll just run this again. So here I'm going to say print out student A's first name, then student A will show off, and then print out their first name again. And based on what we see here, think to yourself, what would you expect to happen? It's not a trick question. First it's Bob, then it becomes wizard. And it will always be wizard now, unless I change it back, but it will be. I'll just go down here and say student A dot ask for a higher mark, 100, and we'll see that like my name is wizard. It's Wizard Smith. I know this is silly, but it's the point to show you we can do whatever the hell we want. However silly we want to be, we can do it. Why did that method make a change to the attribute? Because I could. Does it make sense in this case? I guess so, because I wrote it that way and I'm the one inventing this class. Because remember, I'm God in my simulated world here. So I've got this object, enthusiastic student, and one of the methods will change their first name. Why? Because. And then I've got this one here, work too hard on the assignment. For fun, raise your hand if you've been following along and you actually have this running. All right, well, let's do it together then, because not many people did. So what should we have? What do we want this function to do, this method to do? What do we want to do? We'll take any idea, because remember, we can try to do whatever the hell we want. Increase your grade by 5%. Work too hard on the assignment. Okay. So what we'll do is self dot current average, come on, times 1.05. That's what you mean? And then we can do like times equals. That will basically be like the current average equals current average times 1.05. So increase it by 5%. Then, how about let's also do this then? There. Why? Because. Because why not? Right? Why did I change their name to first name is really tired now? Because I could. Because I could do whatever the hell I want. So I'll run this just to reset things. If I say print student A dot first name cur average, and then we will then do work too hard on assignment. Oop, of course I have to tell which one to do it on. Student A dot work too hard on the assignment. There, Bob 74 is now Bob is really tired now 77.7. Cool. Yeah.
Out of curiosity, would it be possible to do something so like if you were running one of the functions, like that area would just reduce the call?
Say that again. It's kind of hard to hear because of the mask.
Just weird idea I have. Like, so if you were to say, well, you make it so work too hard on assignment, it just means that variable won't like work in call. Like if you would say student A works too hard on assignment, then try to print student A on A, it wouldn't work. Or
I'm not quite sure what you mean.
never mind.
Okay.
I'm not sure it probably means it's gibberish.
Well, it's also kind of hard to hear, so maybe that's part of it. But maybe we can revisit that one. Other questions about what we're looking at right now? Okay, there are a number of special functions or methods that we like to have. Many programming languages kind of have like their expectations on what are standard methods you might want to have your class to have. Because there is a bunch that you kind of want, there's a bunch of methods you kind of want all of your classes to have, regardless of whatever type they are. I mean, you don't have to have them, but there are a couple of common ones. One is the equals. Yeah.
How can you put a bunch of like self-made classes into something that you need to import, like math, for example?
Yeah, you could totally do that. All you have to do is make it like it's easier to do if you're doing it like PyCharm. So what you can do is you write your whole class in a certain file, and then you can say like in another file, assuming they're in the same working directory, you could say import whatever I called my class. And then you can access all of that stuff. Yeah, it's pretty cool. In fact, I think there are some examples in here, I think. We'll see. But yeah, that's how you would do it. And typically, a good convention to follow is one class per file. So if you want to have like two classes, put them in separate files. Yeah.
What happens if you just do print student A? Without the dot, so now it's dot plus any class, we just do print student A.
That's a very interesting and well-timed question. Print student A. Well, what do we see?
The location of student A.
It's the location of student A. In fact, I always get confused because some programming languages are different. I'm not sure if that's the location or if that's like its hash value, but let's not worry too much about that. Let's just pretend it's the memory address. I'm pretty sure it's the memory address in Python, I think. Either way, it doesn't matter too much anyways. Point is, it gives you a bunch of not that helpful information. But often, if I print out a student, when I print out a list, what do we see? We see open square bracket, the contents, close square bracket, right? But someone had to write the code to say, well, if someone says print out something that's a list, this is what you do. Well, what happens if you want to print out a student object? Well, by default, it gives you this. It gives you the name of the class and its memory address. The address of where the instance is, I think. Again, it could also be like the hash value, but let's not worry about that right now. So that's not very helpful. So maybe what I would want is to say, well, no. If anyone ever wants to print out a student, like if I say print student A, I want it to print out like their first and last name, student number, and current average. Why? Because. And one of these fancy methods called repr Did you look ahead, or is this just very coincidental?
A mix of both.
Oh, okay.
I had an idea that something wasn't going to work as I started the fourth assignment. But I did not look ahead, did not know this happened to be next.
Okay, so I'm going to go into the class, go back here, and add to it this one. So repr, all it's doing is saying first name, last name. Well, here, I'm going to run it. And then I'm going to go recreate the instances. We can get rid of this. Get rid of this. Print student A now. Well, now we see all this information. Bob is really tired now. What? Bob should not have. Okay, let's do this again then. All right, there we go. So there we go. Now when you print out student A, it gives us much more useful information. What information you want here is entirely up to you. Maybe you say like, their current average shouldn't be printed out. Fine, get rid of it. Doesn't matter. This, within repr, is where we say, well, if anyone ever tries to print this object out, then this is what I want you to do. If you don't write the repr, you get one by default. That just says class name, memory address. Now I'm saying, no, don't listen to that one. Look at this one. We override the default one and say this is what I want it to do. Yeah?
Why does it have to be called reference?
Why? Because notice that, like, so this is a function, because first it's a special one. There's a special name for these in Python. I can't remember what they're called. They're like magic functions or something. I can't remember. But you'll notice that like when I called the method work too hard, I had to say student A dot work too hard. So you might be saying, well, why am I not doing this? Right? Which totally works. But the handy thing here is this is one of those magic ones where you go like, well, you actually don't need to do that. Because in the context of ever trying to print out this thing, it'll automatically go and call the repr. In other programming languages, they'll have other conventions. For example, in Java, it's toString. So in Java, you'll have something called toString, where you can say print out reference to the object, and it'll run the same way, but instead of looking for a function called, or a method called repr, it looks for toString. It's the same idea, though, just different labels. So yeah, there we go. It's special. We don't actually need to call the method explicitly. It kind of does it for us. Now, one thing I want you to pay special attention to, because every single year people mess this one up, and this year will be different because I'm making sure you're listening and paying attention. Does repr print anything out? Everyone say no. Your repr should never, ever, 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 ever contain print. What repr does is it returns a string that you could print out if you wanted, but it doesn't print out the string. It gives you back a string. Pay attention to that. It's important. So repr is a really important one. In fact, yeah, we can also, well, yeah, it's the same idea. So yeah, repr is one of the important ones. There are a bunch of other ones too. There's a long list of cool special ones we can include, like we saw at the end of last class, the EQ, right here. What does it mean for two enthusiastic student objects to be considered equivalent? Right? We could ask the same thing about lists. Remember, what does it mean for lists to be equivalent? Well, if they have the exact same contents, we say they're the same. But someone had to tell Python what it would mean for a list to be considered equivalent to another list. Well, here we've got enthusiastic students, and if I check if they're equal, it's not going to be overly helpful, I don't think. In fact, let's see what happens. So I have, I'm going to create one more. Student C equals student A. Okay. So if I go here and I say, student A, is it the same as student B? False. Oh, that makes sense. Make another one. D. So now we have A and D that they actually are identical, right? So now what happens if I do this now? I'll run this just to make sure I ran it. False. Even though they're the same. They're both Bob Smith 1, 2, 3, 4, 5, 7, 8, 9, 74. What's up with that? They're the same. But Python doesn't know because you never told it what it means to be the same. Interestingly, though, if I say student A equals student C, we see true. But that's because A and C, student A and student C, are pointing, like they're references to the exact same one single student object, right? To this one, right here, not the bottom one.
So instead of checking if the inside's the same, it checks the actual pointers, and unless the pointers are the exact same.
Yeah, it checks if they're literally the same object. Not if they're equivalent. I mean, if they're the exact same object, they would be equivalent, of course.
Yeah.
But it doesn't actually care about the contents. It cares about, like, is this the same actual, like, literally the same object? That's what it does by default. Just like repr by default just tells you the memory address. So we can define our own EQ. Oh, I'm going to go, I guess, right before repr, because why not? There. Run it. So now we are saying, we are telling Python, if these two things have the same student number, they're equivalent. That is what we are saying. Because it shouldn't be possible to have two people with the same student number unless they are the same person. So here, Bob Smith and Tom Paul. Maybe Bob Smith changed their name, I don't know, to Tom Paul. And here again, take note. This one, it's like I'm asking a specific student, are you equivalent to that one? So I'm asking the specific one, self, so it has to say, okay, self, student number. Then I need it to be like, okay, well, the one I'm comparing myself to is student number. So self is me, the other one, another thing. That's the reference to the other one I'm comparing myself to. So now, okay, I'm going to run this, run this, run this. So A and C are the same. Well, okay, that still works. And that makes sense in both ways. Like, okay, if they are literally the same object, they also literally have the same attribute student number that's identical. But now if I say D, well, it's also true. And B, well, it's also true because their student numbers are the same. So now, underscore underscore EQ lets us make use of equals equals to compare two instances of these objects, which is pretty cool. But again, if you're saying like, but what does it mean to be, like, how do I know what it should be? It's up to you. Unless I'm specifically telling you, like, oh, two countries are the same if they have, you know. But, oh my God, really, there we go. But you get to define it however you want. And similarly, like with repr, I could say, oh, maybe not. What am I doing wrong here? Oh, wait, what the heck? E-N-T B. And I think I have an extra parenthesis. There. So it's true. Now I'm calling EQ. Don't ever call your reprs or EQ this way. Don't. Because the whole point is that you can kind of hijack the equals equals operator. Or the print, it just knows to call repr. But here, student A, I'm saying, okay, student A, are you equivalent to student B? Well, when it goes and runs this code, self will be pointing to which one? Student A. And another one, or pardon me, another thing would be pointing to student B, or the thing that student B points to. Yeah, good. But again, don't do it this way. Do it this way because this is much nicer, isn't this? It's much prettier. There are a bunch more. Do I include them here? Okay, enthusiastic student. Okay, public, private. I'm just having a quick look here to see if I mention any of the other extra ones. Okay, repper, putting it together. Shoot. Maybe it's in the lab. Pardon me for one moment while I look to see if I want to go on a bit of a tangent.
I want a bit of a tangent anyway.
Well, I gotta be careful. So repper, EQ. Here we go. Okay. In the lab, I have you do a couple of extra ones. So there's underscore, underscore, len, underscore, underscore. Want to take a wild guess what that one will do? It'll tell you the length. If you ever call length, len, something, it'll tell you the length. Now, for a list, that makes sense. You'd probably want to write your len for a list because, well, lists have lengths. Doesn't really make a lot of sense to ask the length of a student. That's rather silly. So I probably wouldn't write this one. But I could, and I'm gonna, because why not? And we can make it do whatever we want. What I'm going to do, don't do this. This is too silly. Def. Whoa. Return. I don't know. What number should I return just for fun?
Why not the length of their first name?
There we go. There. Now notice that I'm using length and length, but I'm asking the length of two different things here. When I said len of first name, which class, where do you think the underscore, underscore, len, underscore, underscore, that's actually getting called when I call it on a string, where do you think that one's written?
In the class definition string.
Exactly, that's the string's length. I am defining a student's length. But I could still use other classes' lengths. So if you're thinking, well, hold on, you're using it in there. Well, no, I'm not, because it's a method that belongs to a different class. They have the same name, but I'm using the string's length. I'm basically hijacking the string's length to give me the other. You know what? For fun, let's do the sum of the length of their first and last name. Great. So now, I did not actually rerun this part, so I never created new instances. So these are the old version. So let's see what happens if I ask the len of student A. Well, it's going to say it doesn't have one. That's silly. But now if I go, okay, let's run this. So now it does have it. I'll recreate the objects. Now do it. It's 8. Student A has length 8. That's rather ridiculous, but we could do it.
What happens if you call length of self within the underscore length?
Well, that would be, we'll talk about that later.
And what do you have to look
Here's another one, get item. Get item basically lets us do the indexing like we do on lists. You know, like my list at index 7, right? So if I had an object that made sense to index, I could write get item and then it would automatically call that one. So let me show you what I mean. So if I do this, if I say student A at index 4, it's going to say, that's not a thing. What does that mean? That is nonsense, right? Because what's that index 4 of that student? You're going to go,
what's the next 4?
Yeah, what that doesn't make that's not a question that's valid. It's a ridiculous question. Until we define it. So for fun, how about this? We'll do def. Nope. Return. What I'm going to do is I'll take It's everyone's phone? That's weird. Cool. All right. My first thought was like, please don't be a fire alarm. That would be so annoying. So what I'll do is I will concatenate the first and last name. And that'll then just give me a big long string. And then I will, and you know what? I'm going to add a space. Because there we go. And then for that, I'll just return that. So what I'm going to do is I'm going to concatenate the strings, and then I'll just index the strings to get me back whatever is that index. So that'll mean what it means to index a student. Enthusiastic student. If you're saying, what? That's stupid. You're right. It is. It's ridiculous. S. 0, 1, 2, space, 4. Smith. S. There. Now we can index enthusiastic students. Why? Because we can. Should we have? Absolutely not. That's ridiculous. It's silly. But whatever. We can do whatever we want. Even if it doesn't make sense, we can do it. There's nothing stopping us. Now, topic 13b, a little bit more about objects. So I'm going to take this here. Go here and make one little change there. And we'll get rid of this one because why not? So this is basically the same as before. I got rid of the extra stuff like the repr and whatnot. But I made a little bit of a change. I added an underscore before this attribute name. And what this means, and this is another one of the conventions you follow that Python semi-enforces kind of. Mostly it's IDEs that actually kind of enforce some of these conventions. But what this means, what this tells the individual, when I look at this code, because I see that attribute first name, last name, student number, and current average are starting with underscores, that tells me that these are private values. These are values that I'm not really supposed to see. I can see it. Like the code within the class is very well aware of the attributes it has. But down here, if I go here, remember how I was able to do like, first name, because I didn't rerun it yet. And it works, right? So now when I do this, I'm going to run it. This has been run. I'll just do it again just in case. Run, run. Now we see first name. And you see, it's not showing those that start with an underscore anymore. I can still get them. I can still do it and get Bob. But you'll see that, like, Colab is now saying, like, no, there's nothing there that starts, there's no first name. It's because these are supposed to be private attributes. These are attributes that maybe we want to have very special control over. We want to have control over how they're modified, how we can access them, if they should be accessed. There's going to be, when we talk about our list class, How many times have you ever said like the name of my list dot and got an attribute from that list? What?
I've done it a few times.
Well, which attributes? What attributes were you getting?
Well, list, append, extend.
No, those aren't attributes. Those are methods. What am I doing wrong here? Oh. So ASD dot. These are all methods. There's no attributes here. There are a lot of attributes within this class, but we don't get to see them. Sure, maybe we could access them, but the point is, I'm hiding this information. The person who wrote the list class is hiding this information from me, the user. Not because they're like, hey, I don't want you to know, but because it's, you don't need to worry about this. There's a lot of variables and attributes that maybe are really important for the functioning of the class. There is a lot of crap going on under the hood of your car that you don't need to worry about in order to use your car. They don't matter. So, we don't need, if I don't need to give you access to an attribute in the class, I won't give you access to it. If you do need access to it, well, okay, then we'll talk about how we might want to control these things. If you ever then say to yourself, well, why wouldn't I just make everything public? It'd be so much easier. Okay, but the whole point of having things public and private is, so the opposite of private's public, is that you can be like, okay, well, these are the things that I want you to have access to, and here's the things that you don't need access to. So it simplifies things, right? Like if I said ASD dot, and I got this giant list of all these things that maybe aren't important for me, but are important for the inner workings of the list class, it's going to be kind of like, whoa, gee, what the hell? What do I do? Where now I go like, oh, okay, I can append, clear, copy, count, extend, index, insert, pop, remove, reverse, sort, and there, we're good. So it hides a lot of this stuff. Those are private attributes. So, okay, public, private. Long story short, public attributes methods are visible outside the class. Private attributes and methods are not. Methods could be private too. Again, you can access them, but the point is you're not supposed to because you shouldn't have to. So, okay, why do we care? Encapsulation design. I'm seeing if I give you the example. Okay. And then there's getters and setters. So let's say I have student number, okay? Oh no, let's say it's first name. Yeah.
How can you make a method like private?
All you got to do is go like this. That's all. And then suddenly it's like private. On other programming languages, if you specify something as private, you can't access it. In Python, you're not supposed to. You can, but you're not supposed to. You could actually start it with 2 underscores, and it makes it like very not accessible, but that's something else. So if I have first name, so here I'm saying get student number, set student number. Okay? So if we talk about a student number, each student has a student number. And I want you, as the person using my class, to be able to access the student number. But I want to have control over how you have access over it. Not because, again, I'm being mean and trying to like limit what you can do, but because it helps protect the data. It prevents you from making a mistake with using the class the right way. So for example, if I make student number private, I can never then, or I'm not supposed to say student A dot student number equals something else. I'm not supposed to do that. But what I can do is use getters and setters. In this case, I would probably only write a getter actually, where I could say get student number, and it gives me back the value of that student number. But I probably don't want to set student number, because probably once a student number is set, it doesn't change. So yeah, sure, you can get that information, but you can't change it. So I make the thing private, and then I can manipulate, access whatever the data that I want through these getters and setters. It's like length is kind of like what, right? Len. Like the list knows how long it is. It's probably got an attribute inside of it that's its length. But when you call len, it just returns that value. Len is kind of like a hijacked getter. First name, for example. Oh no, and then for student, no. First name. Sure, maybe the person changes their first name. And we want to be able to get the first name. And you could make it public, and then you can just easily change the value of the attribute by saying student A dot first name equals new name. But maybe I want to have more control, or maybe I want to limit the amount of control you have over this. Maybe what I want to do is like, okay, great, yeah, you can access it, so there's a getter. But if you have a setter, maybe what I'll do is I'll make sure that your name only includes letters. So if you try to set it to a string that contains numbers, it'll say, no, I'm not doing that. Because then now you've protected like the integrity of that data. All right, we'll pick up here Friday.